Good evening, everyone. This is the fourth regular meeting of the BCS SPA Specialist Group this year. Despite the coronavirus, we've kept the program going, and I'm very grateful to everybody who's here tonight listening. I'm also very grateful to Pradeep Bhadani, who's offered to give us an introduction to Terraform and the Google Cloud Platform and how you marry the two together. Best practices and so forth. And it's a fairly technical subject, so I hope you're well fortified and ready to learn. We've got a further meeting this month, actually, on the 23rd of June, which is in combination with the Business Change Specialist Group, and the speaker will be, once again, Tom Gill, giving us the benefit of his knowledge. That's on the 23rd of June, which is also a special day for women into computing. So I think that's a subject that Tom will be touching on. Yeah, I mean, I don't need to tell you about emergency exits and where the toilets are, because you know that. And I'm afraid we won't be able to go to the pub afterwards. But anytime during the meeting, if you're interested in asking a question, please do so in the questions panel, and I'll try and bring that in at the appropriate time. For now, I think I've said all I want to say, and over to Pradeep.
Thanks, Imo. I hope everyone is keeping well and healthy. So today's topic is around Terraform. So I'll be giving a introductory talk on Terraform, how to set up it up, how to get started with the Terraform, and particularly in relation with the Google Cloud Platform. I'll do a quick demo around like Google Cloud Platform UI, where are things and what are the unique points of Google Cloud Platform as well, and how it can help us to do development in the cloud environment as well. I hope everyone can see my slides. Imo, can you see my slide? Okay. So
yes,
yeah,
it's quick about. Sorry, I had to find the panel to unmute myself. Yes, everything is fine.
Good. So quick about me. So I'm an IT consultant with more than 8 years of experience in variety of domains and technologies like big data, cloud, particularly AWS and GCP, and DevOps. Recently, I've been recognized as Google Developer Expert in Cloud by Google and HashiCorp Ambassador for my contribution in the open source community by HashiCorp. Also, I'm a Google Cloud Authorized Trainer. Feel free to check out the blogs. I try to write around Terraform or GCP on my blog post. This is just for my services. I'll skip that. So the agenda for this talk would be on like two stage. Like first, we'll just quickly learn what is Terraform in its introduction, and then we'll see what Google Cloud Platform offers, and then we'll just jump into the demo where I'll be doing a live the Terraform, the code running and going through the different Google Cloud Console bits and pieces. And if you have any question at any time, please feel free to put on the question box, and yeah, I'm happy to take it. Or if you have, we can take it on later on as well towards the end of the session. So the Terraform is an open source tool, which is built by a company called HashiCorp, which allows to version the infrastructure code. So like we version the code, application code in Python or Java, the idea was to put the similar concept to build the infrastructure instead of building the infrastructure maybe from like very long shell scripts or from UI and all those stuff. So in a nutshell, the Terraform helps to follow the principle of infrastructure as a code, where we write infrastructure or define infrastructure in a code which can be versioned, which can be modified, change, update, delete, etc. Everything code. Terraform.io is the official website of Terraform. The documentation is almost up to date on the website. So I'd recommend, if you are looking for the latest documentation, please always check terraform.io. If you are looking to, as the Terraform, HashiCorp releases Terraform very frequently, generally like one minor version, generally in like 2 or 3 weeks. The website always shows the latest documentation, but in case if you're using the old version of Terraform and it's still not upgraded and you're looking for a specific one, then you can go to the GitHub code and just go to that specific version and then see the code, then see the documentation there. Let's talk about the Terraform features. Like these are the few features which are code to the Terraform. The first one is the infrastructure as a code. It really helps to define infrastructure in a code way. It has its own language called HashiCorp language, HashiCorp configuration language, which is HCL. It's a declarative language, so we define like what we want, and it figures out like how to do this that stuff. As this is a declarative language, we don't get the full power of a programming language like really extensive for loops or if else condition and all those stuff. In the current version of Terraform, there are support of for loop, for each, and if to a certain extent, but we can't expect the full programming uh, capabilities, maybe like switch cases and all those stuff. The unique point for Terraform is like the state which it stores, which means Terraform, let's say I define a code with a Terraform and create some infrastructure using a Terraform. It knows what it has created. And those information is stored in a file which is called a state file. This file helps Terraform to understand what the current state of the infrastructure, and if there are any changes to the code, then it can see, okay, what is the desired state of the infrastructure, and then it can find a path from the current state to the desired state. Also, it is really intelligent in inferring dependencies between the resources. Like imagine I'm looking to create like 3 virtual machine and I want to put a load balancer in front of that. If I bring that infrastructure using a shell script, then I need to code a load logic like my VM machine should be up, then the load balancer service should be up and running, and then only I can point the load balancer to the virtual machines. I cannot put the load balancer to the virtual machine before the virtual machines are up and running. So these kind of dependencies, Terraform can figure it out automatically. There are some certain cases where if you need some dependency which Terraform is not able to do that, maybe because there is some like limitation, bug, or that's not really like a resource dependency. It is what we want from the application. Then we can also put explicit dependencies in the Terraform. We can run a plan before doing anything. Once we have a code ready in the Terraform, we can run execution plan which shows what Terraform is going to do on using this particular code on the maybe cloud provider or any other different provider. Once you're happy, then you can run it. If you're not happy, then yeah, you can update the code so that it is giving the desired like a plan what you are expecting. Also, as I mentioned, like the dependency, it can figure out what dependency, what depends on what. So basically it creates a graph, which we can also visualize in a diagram format. It's like from my experience, I generally use only when I started with Terraform with very small infrastructure. As the infrastructure goes really big, this graph will also like become big and it will be really hard to understand that graph uh, in the diagram format on a screen or something like that. But it's useful sometimes to debug some issues if you feel that the resource dependency is not working as expected, then the resource graph helps to see what's going on. Also, Terraform doesn't do like serial execution by default, which means if I'm creating 4 resources, it won't create resource like one by one. It can create resources in parallel, provided the API support that. The default parallelism is 10, so it can create 10 resources in parallel. That number can be changed. And for some reason, if you want like in a serial way, then we can just set the parallelism to 1, so it will create resource one by one. Here are the few concepts of Terraform. These are not the all, but these are the core concept of the Terraform. First one is the provider. Provider is a special concept in a Terraform. What the job of the provider is to allow us to interact with any API. For example, if I want to interact with Google Cloud Platform, I will use Google Cloud Provider, and that provider will help Terraform code to interact with Google Cloud API and also like take care of authentication and other different types of interaction. We just need to provide the parameters. For example, let's say if I'm using a service account to interact with the GCP, then I just need to provide the maybe the service account path or something like that, so that the provider can then handle the authentication and different interactions. Resource is a fundamental object you can imagine, like it represents any infrastructure object, uh, for example, a VM instance, a security group, a VPC network, etc. Anything, these are like infrastructure object. These are termed as a resource or represented by a resource in Terraform. Terraform modules allows us to define a collection of resources in a particular way. I generally uh, uh, put module as kind of analog to a function in any programming language. Like if I have a function called sum in a Python, which gets 2 arguments or 3 arguments, and it produces the sum of it, and or a library which can be used by different teams, projects, or different people. They don't have to write the code from the scratch. The similar thing in the Terraform module, you can define infrastructure in a particular way, which can be consumed by different users in a same project or a different project or in open source community. They don't have to write the whole Terraform code from a scratch, but they can just reuse the same code which is being written by someone else. So it's all really allows us to do code reusability and collaboration with different team members. Data source, there are some situation where probably we want to read some infrastructure information which is not created by the same Terraform, maybe created by some different Terraform or created by some other way. For example, I'm creating a VM instance and I want to provide a VPC network name in my VM instance config. And probably the my Terraform configuration doesn't create network. It is already created by maybe some other team or by some other Terraform project. I just have the name, but not the full ID. In those cases, I can use Terraform data sources where I provide some filter queries, and Terraform can then interact with the cloud APIs to get me that VPC ID or something like that, which I can use in my Terraform code. So it's kind of a read operation on existing infrastructure resources, which may be created by the different Terraform code or manually script or by any means. As I already touched about the state, it stores the information about the infrastructure. There are two types of state, or the local state and the remote state. When we start with the Terraform, by default, we are working with the local state. What it means is the file which keeps all the information is stored in our local disk from where we are running the Terraform. For example, if I'm running Terraform code from my laptop, then that state file will be on my laptop. That's okay if I'm starting with Terraform or small infrastructure, but that's not a really a good option to go, like, because for example, if I lose my disk on the laptop, something crashes or something, or by accidentally I delete the state file, then there's no way to get back that state file. That means the resources which was created by Terraform becomes orphan. I can no longer manage that resources using the same Terraform code. If I run the Terraform plan or apply, it will try to recreate. We'll see this thing in the demo and it will become more clear. So the another one is the remote storage. So which means we store the state file in some remote storage, maybe on S3, Google Cloud Storage, console, etc. So that the file can be out of our vicinity, like on the local. It can be also it allows to share with different team members. Imagine I'm working with my 4 different team members, and if I have my local state in my laptop, it's really hard to share the state file with others to see like what has been created or what the infrastructure changes needs. When we have a remote state, it becomes a lot of these things becomes very easy. Also, remote states automatically comes with a locking feature, which means no two users can run the Terraform code or change the infrastructure at the same time. So it uh, has those features inbuilt. And if we are putting on like S3 or GCS, we can just enable the versioning on the bucket so that if by mistake, if something or someone overwrites the state file or deletes, we still have a version to recover from it. Are there any questions till this stage? I'm not sure where to see the questions on this GoToMeeting. I assume I can't see any questions, so I'll just
yeah, the questions would come up here in the questions panel, and at the moment there aren't any.
Okay, I can see. Good, good. So few benefits which I feel Terraform provides, like one is the code reusability. Once in an organization or in a team you start writing Terraform code, after a while you will feel that you are maybe reusing most of the code. You're not right, probably don't have to write like a new code. For example, if I have a code to create one virtual machine, and if someone in my team or in maybe in a different project want to create the virtual machine, they can just reuse that code. They don't have to do everything from scratch. So that becomes easy, and mostly from the Terraform module perspective, it's really easy to reuse the Terraform modules. We'll see like in the coming slides, there is Terraform registry where you can find some open source module as well. So if you're starting with some cloud provider very and you're a new and you want to do some stuff quickly, you can just look for some open source modules and quickly do some stuff for maybe for POC purpose or something. And if you're happy with that, maybe you can just progress with that. It's really easy to manage the resources, like doing anything changes on any resource, for example, security group change or description of VM or any properties of VM you want to change it later on once it's created. It's really easy, or you want to delete the VM altogether, increase the size, etc. You can or put the resource tagging, most of the resources which allows resource tagging in the cloud provider, you can do via Terraform so that it can be the tags can be consistently applied to the resources. Over the time, you will see that you'll save a lot of time and money because of the code reusability. You can manage the infrastructure in an efficient way. Also, as it's done in automated way, you just need to run few Terraform commands. You can quickly bring up the infrastructure and destroy when it is not needed. Let's say have a fairly complex architecture where you have few virtual machines, a VPC network, few security groups, and few other resource objects, and etc. If you have to do that by script or by UI, and you need that infrastructure only maybe for a few hours a day, maybe let's say 4 hours or 5 hours, it will be very tedious to bring up that infrastructure every day in the morning and destroy maybe in the evening, and that will be error prone as well because you are doing through UI or scripts or something like that. But with the Terraform, once you define the code, it is always gives the consistent output. So if you need the infrastructure only for 4 hours, you can just quickly run Terraform to bring up. Once everything is done, you don't need the infrastructure. You can just destroy the infrastructure, and you basically use the cloud the way it should be, like you pay like based on your uses, and then you pay what you use. So there are a lot of savings on that front, and also like the time, you don't have to invest more time in building the infrastructure. Let's quickly see how the Terraform lifecycle looks like. It's like a fairly easy. I generally divide it in 4 steps. Like first one is init, or you can just say like where we write like author the code, like where we write the code and then we just want to initialize that code. That is done by the command called Terraform init. When I run a Terraform init, what it is going to do, is going to scan the code and see what providers, plugins, and it has to download from the internet. It will download all those packages and keep in the local directory so that I can progress further. So it's kind of inferring the dependencies and everything and downloading them. Once the Terraform initialization has been done, run Terraform plan to see the execution plan, what my code is going to do. If I'm happy, I can just run Terraform apply. At that stage, it will start interacting with the cloud APIs and it will start creating or changing the resources based on the code. If I no longer need that infrastructure, I can run Terraform destroy and it is going to destroy that infrastructure, and you don't have to pay after that because the infrastructure has been gone on the cloud. Installing Terraform is fairly straightforward. For Mac, you just do pre-install Terraform. I've already also written a blog, which is the link is here, which has details like steps and the output as well. For Linux user also, like grab the zip file, put in somewhere in the path, and the Terraform is done. For this demo, we'll see how the Google Cloud, what Google Cloud provides, and we don't need to install this thing also on the local if you're using Google Cloud shell, etc. That we will cover in the demo. To interact with Google, we also need, if you are using our laptop, we need to install gcloud on our local laptop so that we can have like the Google Cloud SDK installed on the local. Again, we'll probably use the Cloud Shell, which already comes with all these bits pre-installed, so we don't have to install these things on our laptop. So just a quick on the Google Cloud Platform. I'm not aware of the backgrounds of the attendees, so I'll just give a quick introduction. So Google Cloud Platform provides services like in different areas like compute, storage, big data, machine learning, and these services are provided by Google on the Google infrastructure based on the information in the public domain. It for many of the Google products like maybe like the Gmail, G Suite or something, Google uses the similar or same infrastructure and the services to power its own services. So it's fairly very mature infrastructure or the services provided by Google on the Google Cloud, on the Google infrastructure. If you want to read more about, you can just go to the cloud.google.com. There's all the information about the Google Cloud. A few of the services which I've put, this is not the full list. The full list can be found on the website. And as this is a fast moving space, new services come up or like services gets promoted from alpha to beta to G or something like that. So I always recommend to always look onto the official documentation, what the services are and what they offer, because the documentation also change from version to version. For compute, for example, Google provides, these are not the full list in the compute itself. I've just listed like 5 in each categories, and there are different categories as well. There are more categories. So like compute engine is like virtual machines. App engine is again a different serverless kind of service. Kubernetes engine, it's like a GKE. Cloud Run is like serverless service to run Docker containers. Cloud Functions is again like serverless technology where you run your own code in provided and the Google run like provided runtimes. If you're aware of, if you're from the AWS world, the Cloud Function is similar to the AWS Lambda. In management, you have different functionalities like Stackdriver is really a nice service, which I like. It provides like all the logging, reporting, monitoring, everything is built in the Stackdriver. And are really well integrated with the Stackdriver. So you do anything on any services, you can see the logs in one place. And the Stackdriver. Cloud Shell, which I talked about, it's like the online, you can say ID or online development environment, which we'll see. It gives us like, Google gives us like a 5 GB of persistent disk, and there's a virtual machine attached to it so that we can run our Unix code and everything on the cloud. We don't have to install utilities on the laptop. Where it helps is like, for example, if I use the Cloud Shell, which means like if I'm working from my laptop, I can just log into my Google account, do the stuff. And for some reason, if I'm not able to access my laptop, if I have some other laptop, I can then just again log into my Google account and I have all the development environment, everything set up on the cloud. So basically, I'm not dependent on my particular laptop or a workstation. In storage, like cloud storage is like object storage. Cloud SQL is like a managed relational databases. I think it comes with MySQL, SQL Server, Postgres, etc. Cloud Spanner is the global transactional relational database. And in networking, again, you have like virtual private cloud, virtual network, etc. So like whatever the services we need, maybe we require to build our own data center, maybe you can say, or and some serverless technology where you don't have to even manage the infrastructure. You can just bring your code and just get started with that. So now it's a time for the demo. I'll be using some code which is already on the GitHub on my GitHub. So this link will be on the slide. I'll be sharing this slide on my LinkedIn after this talk. So please watch out there. I'll be putting there. So I'll just click on that. But before I jump, okay, let's quickly give me an introduction on this one. So all those steps which I mentioned to install Terraform or gcloud, everything is on the README. So they're on the slides, they're on the README, they're on the blog. So whichever thing, like channel is comfortable for a person, you can just refer that. Let me just get the console.cloud.google is like where you guys can still see my screen. Yeah. So this is a home page for the Google Cloud console. Google generally gives like $300 free credits when you sign up. But I would just recommend just search on the Google and just check for the latest documentation what it provides for the free credits. I think it needs well, you need to probably put your credit card information and everything. But I suggest to just check out like the local like the latest documentation. Once you're once you're on this Google Cloud Console, you have this menu where the navigation menu where it lists all the services. So you can see like the services under compute, the services under storage, networking, etc. You can get all these services, you can use it. You can also search those services in the search box. This thing gives the project where you can just choose your project you want to work in the Google Cloud Console. Here you have the dashboard of the project. It gives the project name. The project ID is always unique across the globe. So if someone has got that project ID, for example, if I have got this project ID, even I or some no other people cannot just reuse the same project ID. This is unique, and this project number is also unique. This project name you can put as you want, but the project ID is generally unique. If you delete that project, still you can't use that project for some time or maybe indefinitely. I have to like check like what's the latest on that. But for sure you can't reuse until this project is completely gone. This the dashboard is also customizable. You can customize from here. This what you want to see, what you don't want to see based on your requirement. This activity, what activities are going on, etc. And you can see like what resources are there, and how, billing also shows like what charges you have been incurred, etc. Just to keep an eye an eye on like the charges. Now this button is to activate the Cloud Shell. The Cloud Shell is like a small virtual machine on the cloud. It comes with a 5 GB of persistent storage. When I click activate, it is going to create a new virtual machine, but attach the same disk which I've been already using, so that I don't lose any data. So if you want to persist the data, just put in your home directory. That home directory is always persistent. If you put something outside home directory, for example, user local bin or something, that's on the virtual machine. That will go once the virtual machine, the Google recycles the virtual machine. Also, you can have the editor, which is like built using Eclipse Thea, so which is like online IDE. So if some user don't like terminal, they are more comfortable with IDE. So you have that facility as well. I can just bring up in the new window from here, and I'll have the shell and the shell like the code editor, etc. We'll use this code editor in our demo, so you can see like how comfortable is that. You can ignore all these old. I'll just create a new directory and we'll go from there. This VM comes with pre-installed like a gcloud, Terraform, and some other like tools. So you don't have to install that also. It already installed by the Google on these cloud machines. So if I do Terraform version, it has kind of a latest. So like the current latest is 12.26. It has 12.24. It's there. Gcloud is there. I can just do gcloud auth login command. Just let me know if you are not able to see, or if you want me to zoom this text. Anyway, I'll just zoom it a little bit. But if it's still not clear, please let me know and I can zoom it more.
Yeah, folks, you've got a raise hand
It looks
facility
okay?
on. It looks okay to me, but that's fine.
Okay,
But
that's
just
good.
in case anybody has a problem, please use your raise hand.
Yeah, please, yeah, or put on the question box, please, that you want me to increase the font.
I shall. There I go. Thanks.
So gcloud auth login will just tell like, okay, who is the current user which is logged in, or what credential, sorry, not auth login, that is to login, gcloud auth list. So it tells me like I'm logged in with my email ID, obviously, because I'm already logged into the Gmail or like the Google account. So this thing is automatically done for me. That's all set up. So what I'm going to do is I'm going to clone this repository and then start with a fairly simple Terraform code and go from
Just
there.
before you do, Pradeep, it might be worth mentioning how you would do this login if you're running from your local workstation instead of the cloud shell.
So if you're on the local workstation, it's the same, like you have the similar kind of terminal you have. You just need to install the Terraform and the gcloud, following the instructions on this, like they are like a detailed instruction. And once these are set up, then this shell becomes like your local shell or something like that. But if you're starting on Google, I would suggest maybe it's really easy to use the cloud shell because everything is on the cloud. But yeah, for some reason, if you can't use the cloud shell, or if you're more comfortable on your local, then yeah, you just need to install the Terraform on the locally. Does that answer the question?
It does for me, yes. We had one
And
person
let me
asking
just
whether we could increase the font size into more.
of more. Okay, I can do that. Is it better now?
That's great for me, thanks.
Cool. So just like if you just to save the time on the workshop, I'm not installing all these live. But if you are looking like on my blog, what I have done is I've embedded like the installation kind of a video where you can also see like how to do that stuff. So if you want to do it and if I stuck, you can just follow the step, or you can just follow this video as well. Same with, there is a similar video for the gcloud on the different blog. So those links are on the slide. So you can do that as well. Okay. Now I'll just create a directory and I'll just start putting everything here. So you can also follow the same steps. So I'll just do git clone, just clone, and let's see. So there are 4 exercises. Probably we'll touch on like one, like this basic one and the variable, and then this app. Not creating a new project. This you don't have to do all for maybe your routine Terraform or interact with GCP, because when you log in with the GCP, you already get like one project. So if you see, this is a one directory. Anything under this directory, one directory is called Terraform root project, or you can say Terraform root module. You can have more than one file, and the file extension should be .tf, by which Terraform will recognize this is the Terraform code. Generally, when I start with a small code, you can put like a main.tf or something like that. But when you are working on real scenarios, I generally prefer to give a meaningful name. For example, in my infrastructure, if I have few VMs, few storage buckets created, IAM created, and etc., I'll be putting like a separate name for each file. We'll see that in the coming example in this app one.
You know that there's a convention for naming variables inputs, variables outputs and main. Does Terraform actually care what the names are?
No, these are not these are not enforced naming convention. These are like community, you can say community driven, or like the best practice, or like the good practices to keep those name as those files. It gives the readability, and also like if we look for the most of the community modulars, everyone is following the same pattern. So let's say if someone who already have a Terraform knowledge or something and comes to your project, and if you're following the same structure, it becomes really easy to navigate to the code. But let's say if I'm using different names, so let's say maybe abc.tf for storing the variables, then yeah, it will be, I just need to go through all the files or maybe search, okay, where the variables are defined or what else. So just like a good practice to organize the code. And it's kind of everyone in the open source community is following the kind of a similar. So it's good to follow those practices. So first of all, we need to define a provider block, which tells Terraform which provider you are going to interact. If you don't provide this provider block, what Terraform is going to do is, based on the resources, it will identify which provider you are using. So in the resource name, this is the resource name. So Google underscore storage underscore bucket. So it will always start with the provider name. So if it is for AWS, if the provider is AWS, and maybe you're creating EC2 instance, it will be like AWS underscore instance something, but all the resources will be called as AWS underscore something like that. But it is always good to provide the provider, because you need to provide like these kind of details, like which project you are targeting, which region, and etc. And it also gives the good readability. Otherwise, Terraform will ask all these input when you run Terraform plan and apply, and it won't be stored in the code. So everything should be on the stored in the code. We should be avoiding passing parameters through the command line interactively or something like that. So this tells Terraform to use the project with my project name. Obviously, this is not a valid name. So what I'm going to do is I'm going to put my project name. So I can just get my project ID, which is basically a project ID. So I can just put like update this. So in most of the places, what I have done is I've added a comment where if you are following the same code, you just need to update all these stuff. If by any chance, if I've missed or anything, please feel free to raise a GitHub issue or something like that, and I'll fix that. The region, I'll just put London, Europe, West 2 for now. Then I want to create a storage bucket. So to create a storage bucket, the resource name is Google Storage Bucket. And this is like, you can say the block name which I want to give in the code. You can't have, I'll come to that later on. Then the name, what name I want for my bucket. So maybe I'll just put some random character because my GCS bucket might not be available. So I'll just put something like that, just a unique name. Again, the storage bucket are globally unique name, like in AWS S3. So if someone has already taken like one bucket, you can't create the bucket until the person deletes the bucket. And then the location, there are more parameters we can see from the Terraform documentation what it supports. Let me get the Terraform documentation for this one. So all the resources have the very good documentation, and I always suggest everyone to look for the documentation, because these things keeps changing. Always have like some examples to start with it. Then these are the argument, what all argument this Google underscore storage underscore bucket can accept. So based on your need, you can use them. If it is required, which means you have to specify that argument for sure, otherwise Terraform will complain, error out. If those are optional, then you don't have to provide it. Terraform already has some default values. It will just use that default values if you don't provide those arguments. So I'm just providing name and the location, and that's it. So now in the shell, what I'll do is I'll just navigate to the directory. So 01 basic. I can see I have the main.tf. I don't have any other file if you see, right? And in Terraform, nowhere I have mentioned that I want to use like a local storage, local state file or a remote state file. So by default, it is always local state file. So Terraform is going to use the local state file. So first of all, let's say if I run a Terraform plan, it will say, okay, like no suitable version install or anything like that, or all these errors. The reason, because I haven't initialized the repository, so Terraform don't have those required plugins and etc. So what I'll do is I'll just do Terraform init. So you can see it initializes the backend if it is local or remote, whatever, based on the configuration. Then it always is downloading the provide Google. This is the latest version. We can also put like a versioning, like which version we want, like the constraint, but as I haven't provided anything, so it will always try to look for the latest one and download it. And at the end, it will say successfully initialized. If there was any error or something like that, let's say, and if I run Terraform init, it will fail and will try to give, okay, where is the error and etc. So also, like from formatting perspective, let's say if I'm like not formatted code well, all this stuff, which is like looks ugly when you read it. Like this is fairly small code, so it doesn't feel like that. But once the code is pretty big, it feels ugly. If you have like, if you don't have the formatting properly, we have command called Terraform FMT, which will just format the code in a nice way. And also there is a command called Terraform validate. So we can just run to make sure that we don't have any syntactical error or something like that. The configuration is kind of valid for Terraform to take.
Yeah, and
So,
the format command also takes a switch, doesn't it, minus check.
yeah, it also, yeah, do that.
So that gives you a linting capability.
Yeah, yeah. So now I'm going to run the Terraform plan. Let me just make it a little bigger so that it's in the one screen. So it goes through the code and it says, okay, I have defined one resource. And if you see, this will be the name. So this is kind of, you can say, unique name or fully qualified name, which will be like the resource name dot whatever the name I have provided for the block. So this name should be unique. So which means if I copy paste this thing to maybe let's say create another bucket or something, and if I run Terraform plan or something, it will complain like duplicate resource because there are two things which is like Google Cloud, Google Storage bucket dot my bucket, and then again Google Storage dot my bucket. So if I want to have something, I can just do bucket run or something, then Terraform will be fine. So you just need to be a unique name within this whole Terraform code base, within the particular directory in our particular Terraform project. Okay, so let me just quickly run the Terraform plan again. So it says, okay, I want the name like this. The storage class I haven't provided, so it is taking default, which is standard. Anything which you see known after apply, which means these will be computed once the bucket is or the resource is created. So after that, Terraform fill all these values. I'm happy with the plan. It is going to add or something. Let's say if it is deleting or something, if I'm not happy, then I'll probably change the code. For now, I'm happy with the code, so I can do Terraform apply. It will again ask, do you want to continue or not? You need to put a value yes or no. So, but still I suggest to run a plan separately, because if you directly run a apply, which gives you a plan, but by mistake, if you just put yes and you don't want that thing to apply, then your infrastructure will be in a difficult state. So I always suggest to run Terraform plan and only run Terraform apply once you are happy with the Terraform plan. So I can just do yes, and then it will start interacting with the like the APIs, and it will create the bucket. I can just do like gsutil ls, and I should see that bucket. This was already there, so please ignore that. But this bucket we just created with the same name. If you can see, this is the same name, my GCS bucket 342342. Okay, now I can run like Terraform show, which will just show me all those values which are now filled, which were like kind of known after apply. I can see all these things now. Now, if I do ls on my directory, I'll see like an additional file, which is terraform.txt. It's a local storage. It's like a JSON based file. It's advisable not to change this file manually. We should do everything via the code, because if you touch this file manually, or if that file gets corrupted or something like that, and it's then becomes difficult to recover. We can see the content, but we should not touch it. So all those things which the Terraform knows about this Google Cloud Storage bucket, they are stored here. Now, for example, if I just want to maybe change the location, let's say. So by default, Google Cloud Storage doesn't support like changing the location of a bucket like on the fly. For Google, it will be like you are deleting that bucket which is in the Europe West 2 and then creating a new one. So Terraform can infer that. So, and also tells you like what property change is forcing the replacement of this resource. So it says that minus plus, which means it is going to destroy the existing bucket and then create a new one. So says one to add, one to destroy, and why? Because this location has been changed from this to this. So if I do Terraform apply, it will destroy and then recreate it. And bucket is still there, but the location has been changed. If I, let's say, update the name, so I'll just add like one at the end and do a Terraform plan again. Again, like as this is a new bucket name, which means we want Terraform to create a new bucket, and we have removed the old configuration kind of. So it says, okay, the name has been changed from this to this, which means this is a new bucket. So Terraform is going to create a new bucket. So let me just do Terraform apply. So it says destroying this bucket and then creating a new bucket. So if I run gsutil ls, I should see 342.342.1. I don't see 342.342. Okay. So like this kind of way we can manage the resources very easily. Like if you want to change something and all those stuff.
Before you go on, I've got a couple of questions. Can you see them?
Sure. Questions. Okay. That was a scroll. It's a fairly small window. Let me see. If I am an alias in oh, sorry.
I think you couldn't see the whole of the command. So it's Terraform in it, but you only
It's
see
Terraform in it. Okay, maybe it's the
you only
screen
see
share
the
or
last letter
something.
of the Terraform.
Okay. So it's Terraform in it. It's Terraform in it. So it's maybe this because of this thing. I have
line wraps, yes.
increased the font. So it is Terraform in it. So okay. So and I can add anything afterwards. Also, let's say if I just put like force destroy is equals to 2 or something. Once this is created, I can add the different arguments as well. Just to again Terraform plan. So it will say, okay, the force destroy was by default false because we didn't provide it, and by default it is false. And but I'm now providing it is true, so it is going to change it to true. Again, this change can be done in place change. It doesn't have to delete the bucket because Google API supports that. So the still sign, which means it's in place change, it is not going to delete this resource. So let me just do Terraform apply and then just say yes. It says, okay, modification done, everything done, but nothing deleted, nothing added. It's just one change. Any questions so far? Okay, I don't see any question. So now let's say if I'm done with this infrastructure, I don't need it anymore. I want to save the cost. So I can just do destroy, Terraform destroy, and it is going to destroy the infrastructure and it will tell me like what it is going to destroy. And I can just put yes, and it will destroy. Now if I do like gsutil ls, gsutil ls, I don't see that the workshop, the 342.342.1 bucket anymore. It's gone. So that's why it's really easy to manage the infrastructure. And once this is defined like in the code, I can run this code multiple times in a day or every day or something like that. I don't have to worry about running scripts or creating these things manually. Now, if you look, like we have hard coded everything, which means like if you want to change or reuse this code, it's a little bit difficult. That's why Terraform has something called variables, where we can, so this is now a new Terraform project. So we can define the variables and we can pass those values maybe at a runtime or using a file, and we can keep changing those configuration for different projects or something like that. Before we move forward, now if you see, it has the same code, like the bucket has the bucket code, the provider has the provider related code, but those are in different files. For when you run a Terraform plan or something, Terraform will join all these .tf file in one big tf file, and it will see as a one file. So we can create as many as tf file we want to organize our code. Tf file is a special file to provide the value of the variables. Like we define a variables here, and then when we want to pass a variable, either we can pass command line, which is okay in the development phase, but it's always good to use the tf file because the variable values are also stored in the version control. So everyone knows like what values we are expecting to pass.
Exactly, and here's where you can interpolate secrets that come from the environment.
Yes, you can get secret from the environment, or in the Google, you have a Google Secret Manager service. You can get it from there, or you can get it from the Vault, from different places. One thing, anything we put are stored in the state file. So those secrets will be decrypted and put in the plain text in the state file. So that's also benefit. So that's why it's not good to use local state file. When you have the remote state file, at least on, let's say if it's on S3 or GCS, you can encrypt that bucket. You can, based on the IAM roles or permission, you can restrict who can see the content of that file or object, etc. So you can restrict those things. But still, like whoever has access to read that state file can read those secrets in the plain text. Okay, so I have defined like a variable. To define a variable, the name is construct name is variable, then the variable name. In variable, you can have like a description, which is good for documentation perspective. It tells what this variable means. It's not mandatory. Again, type, you can put the types which Terraform supports, like string, number, boolean, etc. It's not necessary. If you don't provide, Terraform will infer it. But from a good practice, I always prefer to put the type also, so that it's clear like what type of argument I'm expecting. Because if I don't provide, and if someone new comes in, you can provide like maybe a list or a map or something like that. Terraform is good enough to convert like numbers to string, string to numbers if it's possible, but still, like if I'm passing a list, then yeah, obviously list can't be converted into the string, or string can't be converted into the list. If I don't want user to pass any values, or if let's say if says user doesn't pass any value, I want to choose something default. So I can just put a default value. So if I'm not passing any value for a region, Terraform will use the default value defined here. To use the variable, this is the new way in the Terraform 12. You just do var.region. You don't have to provide this curly braces and $, etc. like this anymore. It used to be in Terraform 11 like this, which is no longer required. So this thing, but now you will be wondering why I've used here, because here I'm just not passing the variable. Basically, I'm just constructing a string using a variables like concatenate or something like that. So I have to do some interpolation. So to do interpolation, I need to use this dollar curly braces, something like that, so that the name will become whatever the project ID and hyphen bucket, and the region will be like Europe West as default. If I have override, it will override it. Again, the provider, you can see I just setting project equals to project ID, region is equal to region, etc. Now in the TF vars, the project ID is blank. Okay, so let's move to 0 to base variables. Let's say I don't define this in the TF vars, or TF vars file is empty, let's say. First, again, I'm doing Terraform init. It will download in this directory, etc. Now, if I do Terraform plan, it will ask me for project ID. I can pass it here, but this is not ideal when you have multiple variables to declare, something like that, right? You can pass as like command line flag var, then the variable name is equal to value, or var file is equal to whatever TF vars file. But if you don't want to provide anything, you can store in the terraform.tfvars. So terraform.tfvars is kind of a standard file name. If you don't provide, Terraform will always look for this file. So let's say now I've uncommented this and I'm doing Terraform plan. Okay, it didn't ask me for input, but as the project ID is like empty string, which means the bucket name, it has interpreted like this. Obviously, this is not a valid project ID, so the code will fail because the provider won't be able to set on the blank project ID. So what I need to do is I can just copy this project ID and put it here, save it. Now, let me just run the Terraform plan again. Yeah, see the workshop demo, this is my project name and hyphen bucket. I did not provide any region, so it has chose like Europe West 2. I'm not going to create this resource because it's similar what we created. But let's say if I want to override that, so I can just do like a region is equal to, let's say, Europe West 1 or something like that. And if I just do Terraform plan now, it will override the default one and it will pass the Europe West 1. So in that way, we can keep changing the values, don't have to hard code. So if I'm using region at like a multiple places in the code, and if I use the hard coded value, which means I have to change every places, but if I'm using variable, then I just need to change a value at one place, and Terraform will take care of the rest of the things. Okay, is Terraform meant for resource only? Can you use it, Terraform? Install software such as OS or a web server. There are some provisioners by which you can run the scripts, but Terraform, it's not advisable to run like configure like the system, like a big complex system using Terraform, because Terraform is mainly for like orchestrating the infrastructure or creating the infrastructure, not like configuring the systems. For configuration, then you look for the configuration management tools like Ansible or Chef. So use Terraform with maybe in conjunction with Ansible or something. But if it is like fairly simple, let's say if I just want to install few packages like one web server package, which we'll see in the app, the example in the next example, that thing you can do like we can run the scripts when the VM comes up and everything. That's okay. But if it's fairly complex, then yeah, it's better to go for the different solution.
Yeah, I
Like
can add
Ansible
for this.
implementation.
If you can think about it as a simile, if you've got a
Sorry.
big housing development, and this was similarly used by a trainer in Cloud Foundry that I was talking to today. He was saying if you think about somebody developing a large site with a housing development, first thing they do is build the roads and the services out to all the building plots. So you've got roads, street lighting, you've got sewers, water mains, gas mains, cables, and all that sort of stuff running under the roads and out to the individual building plots. And so effectively that site, 20 acres or however big it is, has been paved. So they call it using Terraform to do the paving, and then you use something else, as you say, Ansible or Bosch or one of the other type of provisioning automation tools to actually then build the buildings on that site.
Yeah, that's correct. Yeah, thanks for the analogy. That's really great. And what Terraform is, like Terraform has a provider for like Chef or something. I'm not sure if there's an Ansible. There should be. So you can run those things from Terraform like quickly. So you can basically like glue those things together really easily. So, but yeah, it should be done in a different way, like with Ansible or Chef, if it's a fairly complex configuration. So this is about the variables. I don't see any other questions, so I'll jump on to the next example, where we will see a little bit more things what Terraform can do for us, because these were fairly easy. So here, now you see like I have different TF files with the different names, which I was suggesting, like gcs.tf that creates a GCS bucket, sa.tf where I have a code to create the IAM roles or members or any IAM related stuff, vm.tf which creates a virtual machines, variables.tf for defining variable. I can have version.tf where I can just say, okay, this code is compatible with what type of version, because sometimes there are breaking changes or something, or you want that version, a minimum version to use or something like that. So I can define like, okay, required version is greater than equal to 0.12. So if someone tries to run this Terraform with 0.11 or something, Terraform will give an error. Then the locals is, this file is empty. I think probably I'm not using it. No, I'm using it. So the locals is like some local variables. Those are not the exact variables, but you can concatenate some variables or put some values or define locally in the code base, and you can then use it. You don't have to necessarily define the variables and ask user to pass the input or define some default value. Because if you define as a variable, then the user can override that value. But let's say if I don't want to want anyone to override this web page path, but still I don't want to hard code it anywhere because I might be using this path at 10 different places. So if this path changes from, let's say, web page hyphen slash index.html to, let's say, index2html, I don't want to change it 10 places. So I can just define a locals, and I just then, if this value changes, I just need to change it at once, and it will pass to all the places where I'm using the locals. Now let's go one by one. So what this app creates, I don't have a diagram. I should have got that. Sorry about that. So what it does is it creates a VM, a virtual machine. It creates a one GCS bucket. Let me just get, let's say, is there any online drawings where I can quickly draw?
You could show us the out of that charting command.
Let me just quickly see if that works. So basically what it creates is, so let's say this is a VM. So it creates a VM. Then it is going to create a GCS bucket and put one object in it. So like object will be some files. So some object or one or multiple objects. Then when this VM comes up, it will fetch those objects. The object is kind of a shell script, which VM will pull and run it in the runtime. Then there is a security account attached to this VM so that access can be controlled or what I wanted. So basically this is attached to this VM. Sorry for my bad diagram, but this is like what it is trying to do in the infrastructure it is trying to create. If you see now, I have a backend.tf. Again, this is not the naming or the standard file name or something, but to generally use backend.tf to define the backend. Where I've specified GCS, and then we specify what values, like what bucket I want to use and what is the prefix of prefix I want to use, so that it will create some object with that prefix in that bucket. So I already have one bucket created in this project, which I generally use for my TF state. So I'm going to put that. One important thing is the backend.tf doesn't allow any interpolation, not backend.tf, basically this Terraform, this block, backend block doesn't allow any interpolation. So you can't define any variable or something. So I just put this. And if I do like jsutil ls on this bucket, let's see what all objects are there before we do anything. So it has an app already and default state. This should be empty, but I'll just use different prefix so that we can see that it is creating a different prefix directory or something like that. Then this under the GCS, I'm creating a bucket. I'm calling config, and then I'm also creating an object. I'm calling that as a web page in my resource name. And the name is again the local.webpage path, which I defined here. So this value will be filled. The source will be the path.module is the root directory of the module where we are running Terraform. So I have these files. I want to basically put this index.html to the GCS. And the bucket will be, I can define the bucket name as like here, but I've used like the Google storage bucket .config and the .name. What it does that it will help Terraform to infer that before creating this object, the Terraform should create this bucket. So it will automatically create this bucket and then create the object afterwards. So like infers the dependencies. I mentioned about the data source. Let's see if I'm using any data source in this example. This is a little bit slow to show things. Maybe we can just. So let me just check it out. Yeah. So I'll come to that when I show the VM. So now service account. I want to create one service account. I want to put this name, maybe the display name, whatever. And these are the roles. And again, I'm not using the same service name. I just want to get it from this bit so that these are dependent to each other. So Terraform will create this, Terraform will run this resource block first, and then will run this resource block. And one thing, we are providing the account ID. We're not providing email. This Google service account attribute has an email as an attribute. So once this service account is created, we can read the email like this, like Google service account dot whatever the name we have given here dot email. It will return as the email ID of that service account. Now in the VM, I want to create a VM. So like the name, I'm passing machine type, zone, etc. What type of tags I want. For this boot disk, we want to provide the image name. So either I can provide like the image name as a hard-coded like Debian, something like that, or I can use data source where I say, okay, I want like a image from Ubuntu family and which is in this project. What it helps is if there are image IDs or something gets changed, I don't have to keep changing the image ID here. The data source will always query the latest this thing when we run Terraform plan, and we'll get the latest image ID and fill it here. Then for metadata startup script, it's like when the VM comes up, Google allows us to run some startup script. Instead of putting that file as a hard-coded here, I'm again using some data source, which is template file, which I'll show here, which is under this here. And this is a simple shell script, but it is something like parameterized. It's not a shell script at this stage. Terraform will generate a shell script from this template, which we'll see here. So what I'm saying is take this template, which is this one, then replace these variables which I'm using, so like bucket name, web page path, or something like that, with these values. So when I run like data.templatefile.nginx.rendered, what it is going to do is it is going to render this template file, fill all these values with the variable which we are passing here, and generate a shell script. And that shell script will be passed to a metadata startup script, which Terraform, which Google will use when the VM comes up and install this thing. So to answer your question, Ashok, so like here, I'm using some shell script to install like Nginx because it's fairly like very quick, like to install like one package or something. But imagine if I had to install like a well uh, complex application on, let's say, a distributed system or something like that, I won't be using shell script, or I may be using Ansible, something like that. So now let's just fill the Terraform file again, like the project ID, which I will get it from here. I'll just keep the Europe West one, the name of the app as app. This one, you can change it, some labels like that. I'm going to do Terraform init. So now if you see under initializes backend, it says that successfully configured as a GCS. Previously, it didn't used to say that because we were using local backend. Now it says that rest of the things are same. It downloads all the plugins and everything. In this, we are using a template provider to generate our template. So it also downloads the template provider.
Could you just remind us, backend means where the state file is stored, is it?
Yeah, it's a remote state. It refers to remote backend, which means like where you want to keep the state file and the remote system. Does that answer your question?
Yeah, absolutely. Thank you.
Cool. Now, if I'm running Terraform plan, let's go bit by bit. When I run a Terraform plan, first thing it will do is it will try to refresh the memory in state memory. So if there is already a state file, it will try to get that in memory and do that. As this is a new project, we don't have anything, so that's fine. Then plus again, like to create, so it is going to create a bucket with all those things. Oh, sorry, I moved too much. So sorry. First thing it is going to do is going to infer the data resources to get like what values it will have and all the stuff. Then this data is not refreshed at this stage because this will be computed once we run Terraform. So it is going to do it here. It says like, okay, what is the ID? All this known after the template is this file, which we have passed all with, and it will replace with these variables. It is going to create a VM with the provided information, all those stuff. And if you see this initialized param image, it says like it is going to use this one, right? So it's this version 2020-03-17. Imagine if this change or Google rebuilds this image with, let's say, 2020-06-03 or something, we don't have to change the value and the configuration. It will automatically pick up the new one. All these are VM related. I'll just skip that. I can say it is going to create the IAM members, put the roles onto it, etc. Going to create a bucket and put an object, etc. So let's run Terraform apply. And I'll just say yes. It's creating.
In case anyone is wondering what you would do if you're trying to run this on a CI system, CI/CD like Jenkins or Concourse, obviously you wouldn't be there to type yes. So there is a command line switch to override that.
Yes, but yeah, so there is a command to do auto approve, but yeah, once you're happy with the plan, you can initiate the Terraform apply phase. I'll just demo that as well, how to do that stuff after this. But if we see, it first creates like the storage bucket, then creates a storage object, because to put the object, you need the storage bucket. So it first creates a storage bucket. And similarly for the IAM members, before putting the role, it is going to create the IAM member, etc. Now, I can just quickly go through the different ones. So if I go to the storage, I see this bucket, which I just created, and there should be a web page / index.html, etc. If I go to compute, I will have my VM, this one, workshop demo app. And if I go to this, I should see the Nginx page. It's not displayed, which means still up installing the page, the packages. So what I can do is I can just check the serial output log, what this thing is doing. So it is starting, still in the very initial phase. It hasn't got the startup script. Okay, now it has got the startup script, and probably this thing is, the Nginx installation is completed. It says getting web page from script, GCS. Just do a refresh. Okay, so startup script completes and everything. So if I just refresh that, yeah. So this is the web page which I put on that thing. So that's how it is done. Now, let's say if I change, let's say the label from environment test to staging, right? And do Terraform plan again. Again, it will refresh everything and see, okay, what changes is required. It will check, it will see that, okay, there's a change which is in place, and that's the change. So if you are the CI/CD pipeline, what we will do is like we will run like a Terraform plan, and we'll save this plan to an output file. So -- out, and we can just put any name. So maybe we can do like one.plan or anything, whichever you feel comfortable. So it will generate a file called one.plan. Yeah, it has saved a file called one.plan. And when we run a Terraform apply, we are happy with this plan, and someone approves this plan, then the CI/CD will trigger a new phase, which is apply. Then we'll run something like Terraform apply, then the plan file, and then -- auto approve. Sorry, I think should be before, maybe. Sorry, it should be before the plan file. So it has already started modifying. It doesn't ask for us to yes or no. And if we go to the VM, we should see the tag as staging. Yeah, so we see environment as a staging. Any questions on this and the backend? Okay, so like just before I take questions, if I just look for that backend, so we created a prefix app1. We'll see that, okay, there is app1, and then there is the file name is always default.tf state for Google. In AWS, there is a way to change the name, but for the Google provider, it's not the case because you put in the respective prefix. So you just put your prefix, and then under that it will be one state file, which will be like default.tf state file. Again, if I don't need this infrastructure anymore, I can just do destroy. And yes. And before I put yes, if you just want to see what destroy is going to do, like maybe you want to run a CI/CD pipeline. So instead of running destroy, you can turn Terraform plan -destroy, which will give the destroy plan, and then you can destroy it. Like, I think yeah, it started with destroy and everything. I'll recreate the this infrastructure again because I wanted to show the targeted, like how to do targeted plan and apply if you're working in multiple teams in the same, and team member are working on the same state file on different branches, and you just don't want to step on each other's toe. You can use the target for your development, but it's not recommended to use the target facility in the production or something like that. Just wait for this to finish. Meanwhile, I'll just check if there are any
The
questions.
situation that I commonly encounter is that you have a series of environments like development, test, QA, staging, pre-production, production, some selection of those. And then also you have individual feature development branches. So for each of those, you really need a separate target. But not only that, the different targets mean that you've got different state files, but you also want to avoid name clashes between the resources themselves out there. So how do you keep those apart?
Sure. So here I'm talking about like you have one environment, whatever, like it's dev or test or something, and maybe multiple people are working on the same infrastructure. There you can use target, but if we are talking about like a multiple environment itself, like okay, we have one infrastructure in like a test, then in dev or in staging or production, and there are different ways. There's no standard way how to separate it. I'll show what I generally do with the open source Terraform version. There are some feature which comes in the Terraform Enterprise, which I haven't used because Terraform Enterprise, that might make some life easy. But then again, you have to buy the Terraform Enterprise license, which probably many organizations would not want to buy. So what I generally do is for the multiple environment, like you have this code base, right? You have this code base. You can have multiple TF wars file. Like you can have like dev.tf wars, you can have test.tf wars, production.tf wars. And when I do a Terraform plan, I pass the respective TF wars file, like war file test.tf wars or something like that, so that it picks up the test TF wars file and etc. And for the backend also, instead of providing the backend like this hard-coded, we'll provide all these parameters on the runtime so that we configure the correct backend. So for each environment, there will be different backend and then the different TF-words file. But again, if you're in the same environment and few people are working on different feature branches and want to test in the same environment, what we will do is, so let me just create this infrastructure again, just to apply auto approve. Okay, now let's see if someone like one person wants to do anything to this GCS bucket. Let's say maybe update anything in this, maybe the bucket name or something like that. So what I would do is, let's say I change this one. So this is in my branch. It's not in the other user branch. Other user will still have config. So if I run this, the bucket name will be changed to configs1. And if other user tries to run it, he has configs. So which will try to delete my config1 bucket and try to recreate the configs. To do get away from this situation, what I'll do is, let's say if I want to just run my stuff, I'll do Terraform plan -- target, and I'll just provide my target instead of running the Terraform plan and applying the whole configurations or whole code base. I'll just run on mine. So let's say if another user had changed anything on the VM, I won't be able to see any VM related change. I'll just see my bucket related change here, and I can do that. And if some other user wants to do with the VM, let's say this thing has changed, or maybe let's say there's something like HTTPS server or something like that, then I can just do target Google compute instance.vm. If I do that, I won't see any change which is done for the GCS bucket. So this is okay. Okay, this will do it because it is dependent on the storage bucket. So sorry for the bad example. This VM depends on everything. So if I do any changes to the VM, all the dependency will change. Let's say if I do anything for the IAM, which doesn't depend on the storage bucket. So it is only going to show me the changes or do the changes on the storage IAM, not on the GCS. This way you can work out from this situation.
Yeah, and I have found that it's worth actually not just running the plan, but if you're developing something on a branch. I have a technical leader who wanted to avoid this sort of clash by ensuring that people would only do a Terraform plan when they were in the development branch, and would apply from the master branch once it's been merged. And then we found that actually it's worth running the actual apply in your development branch, because you may find that the permissions haven't been set correct, and even though the plan looks perfect, when you try to apply it, you can't actually.
Yeah, that can be also done. So it depends on, like, because there's no standard way or like the way which HashiCorp or Terraform recommend for this thing. So this comes to like the process. So what type of process is suitable for the team? So yeah, that so for some team, yeah, this is suitable. Like you just run plan in the feature branch and you don't run apply. For some teams, they want to run maybe apply on the feature branch and then again apply on the develop branch, because sometimes the plan doesn't show some errors. It only comes when you do apply. So yeah, these are kind of a process oriented things. And few teams like try out different things and adapt to the whatever suits to them at best.
Okay, we're coming up to 8 o'clock, so I'm going to unmute all participants now. Sorry, Pradeep, I should have asked first. Are you going to do any further parts of your presentation to sum up?
I think no. So after this, yeah, it's a question at time. So
let's unmute everyone, and if there's any questions, you just need to click the microphone icon in your control panel and you can speak.
Yeah.
While we're waiting for that, I would just like to thank Pradeep very deeply for his expertise and for being willing to share it with us. There is a BCS book on its way to you, but I've forgotten what the title was. So that's our little token of appreciation. If all of our guests would like to unmute themselves, we can simply give Pradeep a round of applause for what he's told us. And then there's also another question later.
Thanks, everyone. I hope everyone enjoyed. I'll publish all these slides on my LinkedIn, so yeah, please watch out there. And if you have any questions, further question later on, you can always connect me over the LinkedIn or Twitter or on the GitHub, wherever you feel comfortable. And I'm happy to answer. And if you need any help with the Terraform for your projects or anything, I'm happy to help on those as well. There's a new question from Ashok. How about permissions on the Terraform? Who can get to run Terraform? So those things can be managed by the Google service accounts. So from the machines. So whoever has a permission to interact with Google APIs, they can run the Terraform. So let's say if you don't want anyone to deploy, let's say new project something, if you don't give a service account which has a project, has a capability to create a project, if they run Terraform with those service account, they won't be able to do that. So it comes to the Google service accounts, you can manage the permissions. Terraform is just going to use the whatever the service account you provide, and it is going to use that. In my case, I've used my pradeep.bhadani@gmail.com account, as I am the owner of the project, so I have all the access. So I was able to do everything. If I, let's say, create something new user or some which doesn't have any permission, let's say only has a view permissions on the project, they won't be able to create any resources. So you can control like that.
Right. And anybody who wants to access the GitHub repository that was used in this demo, you can see the slide currently on display, and it shows which GitHub account to open, does it?
Yeah. You can just go to this Cloud Native Tech GitHub. There's that repo, and there's some other examples, or you can go to my GitHub, Pradeep.Bhadani. So there are more Terraform examples. If you want to look for more Terraform examples and everything, so you can find it there.
Well, that's excellent. I wish we could all go down the pub and share a beer, but
Yeah,
as it is, I just have to walk into the kitchen and get one from the fridge. So see you, everybody, on the 23rd of June, hopefully.
Thank you.
Thanks, everyone, for attending. Hope it was helpful. Let's stay in touch.
It was very much helpful for me. Thank you.
And thanks, Emo, for organizing thing and everything. It was really, you put a lot of efforts in organizing this stuff. Thanks,
but I couldn't have guessed just how relevant this was going to be to my current work. So thank you very much for that.
Very good. Thank you. Thank you.
Cheers.
Bye-bye.